Welcome back to Connect and Transform. We're finishing up this project of a graphing SVG today. So I've modified the host file to include different graph types and different colors, things like that. I'll show you real quick. So I've got an example here of non-stacked area. And non-stacked area was actually surprisingly easy. It probably took less than 5 or 6 minutes before it was all working. And you can see I've also got the interaction here with the series labels where you can select different colors and bring different colors to the forefront. I have a special treatment for tooltips for area. Just to simplify it, it's just defaulting to show the series label. So for example, if I have a little tiny peak like that one right there that's just barely poking out, it's obvious that you're on that series. So this graph is an example of non-stacked area, and it's showing suppressed data that's really, really far down on the bottom of the graph because I had to scale this down because you'll recall we're still using randomized data. So as I refresh here, the data is changing every time, and that's not the way that this was intended to work. It's intended that you had real data from which you calculate the y-axis. So because we're randomizing the data, our y-axis is not automatically scaling to fit it, and that's expected. But here you can see an example, though it is a little crazy, it is a functional example of stacked area. Of course, in the real world, it would be a lot more readable. You probably wouldn't have 6 series, and it would look generally nicer, but you can see I've done some slight adjustments to the opacity just so that it's a little bit more obvious which one is selected. Of course, when you're hovering over a very light color, it's still hard to see. Now note on this top graph, if you pay attention to just about this horizontal position here, now note that there's a dashed line at the top of these. That's because I have that work in progress variable set at the data index that happens to fall at about this horizontal position. So what you're seeing here on the graph is you're seeing a polygon, but it's really the stacked line representation plus polygons. So let me go back over to the code real quick, and I'm just going to point out 2 or 3 things that have been edited. I may have edited 1 or 2 things in the CSS. The y-axis, previously this was math.floor with this expression of the number of pixels in the graphical portion of the canvas divided by steps, but that was rounding it to the nearest integer, so it was not making use of the entire area. So I've changed that to parse float, and it's much closer to the actual intention now. So that was just like a 1-line change there. And then I don't think anything really changed until we got to this function here, init data area. Now I'm just going to scan over this function real quick, and then let's keep going down here to line, and you'll see they're very, very, very similar. Your eyes might have been drawn to certain numbers like 5 and 3.5 here. So if I scroll back up to area, you'll see, oh, that's exactly the same. And so basically when I'm rendering an area chart or a stacked area chart, 90% of it is exactly copy pasted from init data line into init data area. And the biggest difference is that we are creating a polygon and we are applying tooltips to the polygon and then not applying tooltips to a circle element, and we're only producing 1 circle element in the area charts, whereas we are producing 2 circle elements when we're doing a line, because one of those is the hidden circle that has the tooltip on it, and that's not necessary for area charts. And then we have a couple of variables relating to the polygon points themselves. So we're keeping track of previous polygon points, and then using that to calculate the attribute points. And I would say the only part of this function that caused the stacked area to take more than, say, 10 to 15 minutes is the portion that I have highlighted here. And this really didn't take that long either. This was probably less than 5 minutes of just thinking about it and trying different combinations of things until it was fully functional. So basically, if we're not viewing a stacked representation, or we are looking at the very first data series, then we want to set the previous polygon points to basically be equal to the main x-axis line at the very bottom of the chart. And so that's what this is doing, is it's saying, okay, use the normal x position, but then use y of 500 to make that point be down at the very bottom of the graph. And then we've got an if-else here for setting our polygon points, the difference of which is whether we are prepending or appending the additional value. And so the distinguisher there is this combination of it either is stacked and we're on an odd series, or we're in the other scenario. And so that took a little bit of thought and experimentation, but again, the whole thing couldn't have taken more than 20 or 25 minutes maybe. I was briefly considering doing a control chart, which would basically call init data line and then also have some rectangular polygons below all the data but above the graph, and have that be like a ever so slightly opaque red or something to say that, hey, you're out of bounds. I might do that in the future, but for now, I think I'm just going to comment that out. That was kind of an afterthought anyway. But yeah, we have stacked area. In fact, let me go turn off the create random data function. So we'll turn that off and then refresh our page here. And then I must have given this a hard-coded y value. So let me go back over here. Yes, that was hard-coded. So let's make that null, and that'll actually be enough to trigger the automatic y scaling. And so there we see that the y-axis automatically scaled to 42,000 with a step of 4,200. Let's refresh again, and you can see that we're no longer using random data. You can see that in this example, the data is now much more readable than it was. And you can hover over here and see different slices of the chart. So let's use the same exact data on this very topmost chart, and we're just going to go through all of the graph types. And I'll move the mouse around and tooltip a little bit so that you can see how the interaction works. So this is area stacked. So let me go back here. Refresh. In fact, maybe I'll just duplicate the page. So this is area non-stacked. So again, that's stacked. This is non-stacked. And maybe just for fun, I'll click on this and I'll bring the purple to the front, and then I'll bring the light green to the front, and then the dark blue to the front. So you have a little bit of control over the actual data that you're seeing. And then with the same data, let's make it a bar representation. And again, I'll just duplicate this page. So same data with a bar representation. Remember, we have our work in progress variable set so that everything from approximately this horizontal position forward is a work in progress. Everything behind that is considered to be truth. Okay, and then we'll do a bar dash stacked representation. We'll duplicate that again. There we go. So there's the original bar and the stacked bar. And just to show again, tooltips, and we can hover over here. And same with the bar. If I didn't do that, we can click on these, we can bring them to the front. Okay, so now we've done area and bar, so let's do line. And we will duplicate this. Okay, so there's our non-stacked line representation. And then we'll do line dash stacked. Duplicate. Okay, so there's our non-stacked line and there's our stacked line. Notice that the y-axis is being automatically scaled. So that's why the data is taking up similar proportions of the y-axis, even though one is stacked and the other is not. So the y-axis is different, and it's actually likely to be very different on all of these. Yeah, so it looks like it's the same. Well, I guess that makes sense. It would be the same for all the stacked varieties and the same for all the non-stacked varieties. Okay, so that's wrong one. Okay. So we've done area, area stacked, bar, bar stacked, line, and line stacked. So now let's do scatter. And we will duplicate this page for the 6th time, opening the 7th window with the same data. And there we have it. So we've produced 7 different representations given the same data. And as we see here, the data can be as simple as this right here, where you might only be providing a single data value and everything else gets automatically filled in. So yeah, that was a fun project, and it's something that I will put to use in the future to visualize other information and data. Thanks for watching.